Okay, so the nonlinear assignment is due tomorrow. I thought we'd look at one more last example. Most of the ones that you guys either saw in class or watched in that first video were kind of like Algebra 2 level problems. Maybe the last one was a little bit more advanced. So I thought I'd look at one more that's a little bit more advanced. I mean, this is totally stuff you could do in lower level classes. It's just, do you have time for it or not, you know? So, Caleb, close your computer. Okay, so I didn't look at the solution to this or anything, so any ideas on what we could do? Remember, we're trying to get the point x, y, where these guys cross. Multiply what by 3, Gary? I think substitution's going to be rough, right? Because you got like an x, y cross term here. So I like what Gary's saying. Gary's saying, hey, if that was like -3 and you added them up, then you have the x, y terms go away, right? Yeah, so let's try that. I don't know, it might not work, but we'll try it. So then we'd have what? 3 minus 3, 3, and of course 18. People mess up elimination usually and by not multiplying the other side, so watch out for that. So now if we add these up, we're going to get 4x squared, that goes away, plus 4y squared equals 40.
Yeah, could you just get the square root each side?
Yeah, but that won't help you cancel anything out or solve for an x or a y. So we didn't eliminate an x or a y there, right? So unfortunately, I don't know if that was a good choice. I like the choice, but it didn't work, right? Because there's an x and a y here. So unfortunately, darn it, I don't think that's going to work. Is there any other thing we could do that would cancel out more than one piece? This was plus, right? And this was 6. So look at it carefully and see if there's any other thing I could do just like that. We'll get rid of more than one thing. There's another clever choice. That was clever, that was good. But it didn't work. If I made this be -y squared, those would go away, right? Ah. So -1, if we multiply it by -1, let's see what happens now. So now if we add it up, that goes away. 3 and that's 4xy, right? That didn't go away. But this also went away. And now we have, what is that, 16? So you're like, well, there's an x and a y left. But see, now you can solve for one in terms of the other. And then you'll be able to substitute. So that will work. So let's see. I'm going to just solve for y. So go like this. We've got y is 16 over 4x. That reduces, right? 4 over x. So now we know what y is in terms of x for this relationship as a whole because we combined the equations to obtain this expression, right? So now we can take this and substitute it into either one, and we'll still have a true expression, and hopefully we can work it down to get some points. Okay, so I'm going to take it and just plug it in the first one. So I'm going to say, all right, x squared plus 3x, and this is another version of y, plus the other version of y squared equals 22. And notice this equation only has x in it, so we should be able to get some of our x parts of our points out. All right, so let's see, this cancels, right? That's nice. That's not going to cancel though. So we've got x squared plus 12, and we've got 16 over x squared equals 22. If I have an equation like that, I need to use the common denominator and chop off fractions. So common denominator of all this stuff is x squared, so multiply it through on both sides. So we got x to the 4th right here, 12x squared for right there, cancels right there, and a 22x squared there. I'm going to set it to 0. Subtract subtract this to that side. Is that minus 10x squared? And I've got that little guy. Man, it'd be nice if that guy factors. Does it? You guys follow me so far, by the way? Is there anything confusing in there? That's all reviewy stuff.
Factor 8
8 and 2. Doesn't 8 and 2 give you 10? Yeah. Sweet. So instead of x and x, what's got to be here?
x.
X squared. Callie said 8 and 2. What signs?
Negative.
Both negative. That times that is positive 16, and negative 2 and negative 8 is a negative 10. Yeah? So it looks like, oh, those are both difference of squares, aren't they? So we can keep factoring. X. What's being squared to give you 2? The square root of 2. Minus plus. Even though this is not a square number, you can put its square root just the same. And there you go. So you have 4 answers, it looks like. We've got positive root 2, we've got negative root 2, we've got root 8, and we've got negative root 8. Except those aren't really the answers to this problem. What are the answers to this problem? It's a system of equations. A system of equations in how many dimensions? 2 dimensions. So we need the y parts. So how can we get the y parts for each point? Right here. So I'm just going to do a couple of them, and we're going to check this on Grapher. Did you guys see in your assignment how it mentioned Grapher? So I'm going to show you how to do the Grapher part of your assignment as well. So if I put root 2 here, then the y for that point is going to be 4 over root 2, which we could rationalize. You guys learned how to do that, but I'm just going to leave it. And then 4 over negative root 2, and then 4 over root 8, and 4 over negative root 8. So one of the points should be root 2, 4 over root 2. So can you guys help me turn that into a decimal? Because we're going to check this on Grapher and see if it looks right. So root 2 I know is 1.414. Let's see, this is 2 root 2. 2 root 2 is 2.8. That's right. Yeah, that's good. So that's what that one is. We're going to see if we can find that point or something kind of close to that point when we look on Grapher at the system of equations as a graph. Okay? Notice you could not plug this in your graphing calculator and solve for y. It's impossible to solve these for y. But Grapher is nicer. It can do that for you. So I'll show you that. So anyway, you should have 4 points, not just that one. One for each one of these guys. Okay? So there's another example. Let's go to Grapher.